When cyanobacteria evolved at least 2.4 billion years ago, they set the stage for a remarkable transformation. They became Earth's first photosynthesizers, making food using water and the sun's energy, and releasing oxygen as a result. This catalyzed a sudden, dramatic rise in oxygen, making the environment less hospitable for other microbes that could not tolerate oxygen. Evidence for this great oxidation event is recorded in changes in seafloor rocks. When oxygen is around, iron reacts chemically with it, it gets oxidized, and gets removed from the system. Rocks dating to before the event are striped with bands of iron. Rocks dating to after the event do not have iron bands, showing that oxygen was now in the picture. After the initial pulse of oxygen, it stabilized at lower levels where it would remain for a couple billion years more. In fact, as cyanobacteria died and drifted down through the water, the decomposition of their bodies probably reduced oxygen levels. So, the ocean was still not a suitable environment for most life forms that need ample oxygen. However, other innovations were occurring. While they can process lots of chemicals, microbes did not have the specialized cells that are needed for complex bodies. Animal bodies have various cells: skin, blood, bone, which contain organelles, each doing a distinct job. Microbes are just single cells with no organelles and no nuclei to package their DNA. The new complex cells, eukaryotic cells, boasted specialized parts playing specialized roles that supported the whole cell. Cells also began living together, probably because certain benefits could be obtained. Groups of cells might be able to feed more efficiently or gain protection from simply being bigger. Living collectively, cells began to support the needs of the group by each cell doing a specific job. Some cells were tasked with making junctions to hold the group together, while other cells made digestive enzymes that could break down food. These clusters of specialized, cooperating cells eventually became the first animals, which DNA evidence suggests evolved around 800 million years ago. Sponges were among the earliest animals. While chemical compounds from sponges are preserved in rocks as old as 700 million years, molecular evidence points to sponges developing even earlier.